All right, welcome to Lecture 2 for Math 141. So, just a review from last time, we were talking about matrices. We were talking about solving systems of linear equations using Gaussian elimination. So remember what this involved. First, we put your equations in standard form and then into a matrix. Then we do a bunch of row operations, and then we read the matrix as equations. Now, last time we only did this for two equations and two variables, and so today we're going to expand that to more general situations. All right, so first of all, step one, put the equations to standard form. This is what we did. We put all of the variables on the left, all the constants on the right, like this, in combined terms. Make sure things are lined up, all the x's here, all the y's here, constants here. And then we put it into a matrix like this. Okay, just put the coefficients in here. Okay, that's step one. Okay, step two, we're going to do a bunch of row operations. If you remember, there are three kinds of row operations. Row operation of type 1 is swap two rows. We never used that last time, but we're going to use it this time at some point. Operations of type 2, multiply a row by a number, and this should be a non-zero number. And operations of type 3, you're going to add a multiple of one row to another. And the point is, none of these change the set of solutions. They don't add any more solutions. They don't take any away. The same solutions are there at the beginning as they are at the end. So as we do more and more of these operations, we're not changing the solutions, but we're hopefully making it easier to figure out what they are. And in the end, we'll end up with a system of equations that just tells us what the answers are. And then the last step is we turn this, let's say we have this, for example, as our matrix at the end. You notice this is in the form that we're supposed to get it, ones here, zeros here. And then we rewrite it as equations like this. This means 1x plus 0y equals 13. This means 0x plus 1y equals 68. Reading this off just says x equals 13, y equals 68. Now, I recognize that some of you might have gotten into the habit of just looking over here and saying, okay, this is x, this is y. Don't do that, because when we do more complicated things, that system's not going to work. I'm going to encourage you to continue to read these off as equations. This says x plus nothing equals 13, and this says nothing plus y equals 68. That's how these are, and that's why x is 13. This one says y is 68. Okay, so don't just read them off x and y, rather read these as equations. Right. Remember, these are the ones and zeros we need to have here. Okay, and that's the goal of these row operations. And you may recall that I did it in a particular order: this one, then this one, then this one, then this one. Okay. So the question might be, what about bigger matrices? So let's say you have more equations or more variables, that sort of thing. So here's the situation for three equations and three variables. So the equations consist of this, this, and variables are x, y, and say z. Okay. If it's of this form, if the ones are here and the zeros are here, then the first equation gets its read x and 0. So x plus 0 equals 8. So that's x equals 8. The next one says y is equal to 2. And the last one says z is equal to 5. Okay, if you didn't quite get that, try looking at that more carefully. Just write each of these equations out, and you'll see that you get these things here. The key here is that there was a single 1 on each of these rows, and everything else was 0. Okay, that's what we want. Okay. And these, of course, could be whatever. They're going to be our solutions eventually. But the important thing is these numbers should look like this. What about 4 by 4? Well, you can see here, 4 by 4, 1's down this diagonal from upper left to lower right, zeros over here, and then these could be whatever. Okay. More generally, what we want are 1's down this diagonal and zeros everywhere else. We're not always going to be able to get that, but that's the ideal. So I've told you what we want to achieve using the Rubik's Cube analogy. That's the solved state. I need to tell you what the strategy is. Okay. Again, we're going to use row operations. Those are the allowed moves. And the strategy consists of an order. Which numbers do I get first? So I'm going to acquire a bunch of zeros and ones, okay? And the order goes like this. I'm going to do the columns from left to right. For each column, I'm going to start with the 1 on the diagonal that I need. After getting this 1, I'm going to use it to get the others to 0. Now, I realize as I'm saying this that there might be some details that are a little foggy here, so don't worry, I'm going to show you an example. And this is just a review here, which operations to use. Whenever I want a 0, I'm going to use an operation of type 3. That's add a multiple of one row to another. This one, to get a 1, I'm going to use an operation of type 2, that is multiply a row by some number. So those are the operations I use whenever I want a 0 or a 1. So sometimes when I say get a 1, okay, I'm going to use this. When I say get the others to 0, I'm going to use operations of type 3. That's not going to change. This is what we're learning today. So the order, we're going to do the columns from left to right. I'm going to first focus on the first column, then the next column, then the next column. Okay. So here's an example. This is a 2 by 2. This is one that 2 equations, 2 variables. We've already known how to do this. We're going to make this a 1, then this a 0, this a 1, then this a 0. But I want to illustrate these principles with something we already know. And the idea is I'm going to start with making this first column correct. Okay, I'm only going to work with this first column. And I start with making this a 1. Okay, that's why I put it in a box. I'm going to do that first. And then I'm going to use this 1 to make this a 0. So I first get the 1 here. That's correct. And then I get the 0 here. And I say I use this one to make this a 0, meaning I'm going to use it in the operation of type 3 here. I'm going to take this, multiply it by whatever the negative of this is, and add it to it, and you're going to get 0. Okay. So that now, when I'm done with that, the first column now looks exactly as it ought to. So now I need to work on the second column. So first make this one a 1. Okay, I'm just multiply by 2/15. And then I'm going to use that to make this one a 0. I just find whatever the negative of this one, multiply it by this row to add it to this. This becomes 0 here. And now everything is as we need it. Okay. So in other words, I'm going from column to column, left column first and then this column next. Okay. And then for each column, I start with the 1. There's each column has a 1 that I need and a whole bunch of zeros. And I start with the 1 first. And then I do all the other ones. I get all the other zeros. It doesn't really matter what order you do the other zeros in. If you like, go from top to bottom just to keep things organized. Here's a 3 by 3 example. So this comes from an equation, a system of equations, where I have 3 variables and 3 equations. The 3 variables are here, that's x, y, and z, and the 3 equations are this row, and this row. So this one would be x plus 3y plus 6z equals 2, and so on. 2x plus 7y plus 5z equals 1, etc. And as before, we're going to start with this first column. And the first column, I need to look at what this one is. I want to turn this into a 1. Luckily, it's already 1, so I don't need to do anything there. Okay, so I want to turn this into a 1. Yeah, it already is a 1, so I don't do anything. And now I'm going to use it to turn these to a 0. Luckily, this one's already a 0 here. Sometimes this happens. Sometimes it happens, sometimes it doesn't, where things you're trying to achieve already have happened. If they've already happened, great, just move to the next step. And I need to make this one a 0, though. I need to make everything in its column 0 other than the one that I need. And so the negative of this is -2. Multiply this by -2, add it to this one. That's what this says. -2 times the first row, add it to the second row. Turns out you get this. Of course, these other numbers are all changing around to other things as well. And now I go on to this next column. So the first column is 1, 0, 0. That's exactly what I want. The second column now, I want to make this one a 1. It's already a 1 as it turns out. And I use this one to make these 0. Okay. Now I kind of did 2 steps in one here. Hope you don't mind here. I'm going to turn this into a 0 and turn this into a 0. So to turn this one into a 0, I take -3 times this second row, add it to the first. That's what this does. Notice this does not change this row or this row. This just changes this row. Okay, and then this one is going to use this times -1 added to the third row. Notice that these do not interfere with each other. This one affects the first row, this one affects the third row, and I'll only look at the second row to figure out what to do. So, and second row is not changing. So that's why I could kind of do them both in one step here. Um, I don't necessarily recommend doing this at first. You can if you want to, if you get comfortable with this. But if you don't feel comfortable with this, just do it one step at a time. Do this one, and then do this one. Okay, so this uses this one to clear this to 0 and this to 0 here. And indeed, look, this says this column looks exactly how we need it. 1 here and 0s at the other places. This is the one where you need on this diagonal. And so now the first column looks good, second column looks good, now the third column. And I need this 9 to be a 1. And there we go. I'm going to take the 1/9 of this to turn this into a 1. So in general, when you do operations of type 2, just take 1 over whatever number this is, multiply it through, turn it into a 1. Now, once I got this to be a 1, I can use this to turn these to 0, and this is how I do it. -27 times this added to this one, 7 times this added to this one, and we get this. Okay, x equals -13. This equation says y equals 29/9. This equation says z is equal to 8/9. All right. This is what I mean by using the ones to get these to 0. I'm using this 1 is in the third row, and then multiplying this third row by something added to this one. Multiply this by the 7 by the third row and add it to this one. So I'm always using this 1 that I attained at this step. And then there we go. This is our answer. Okay, an aside. So this is, by the way, a summary of what we just did. These steps like this, starting from here to here to here to here to here, and we get these equations become our actual solution. One thing I want to point out here is you can always check your work. So I posted the answers to the odd numbers and so on. Actually, you don't need that for these questions because you can just check to see if it's right. I mean, this is supposed to be a solution to the original equation. X plus 3y plus 6z is equal to 2. So we just plug in is 1 times -13 plus 3 times 29/9 plus 6 times 8/9. Is that equal to 2? Just check. And similarly with this 2x plus 7y plus 5z, is that equal to 1? Is 0x plus 1y plus 2z is equal to 5? Plug it in, and it works. So you can always check your work. Next thing is, what happens if you did something wrong? So you notice from here to here, I just, let's say I made a mistake here, and it's easy to do. And instead of 11 at this stage, this is turned from 2 to 11. It's instead, let's say it changed to 10. In other words, I made a mistake in arithmetic here. This one was supposed to be multiply this by -3, add it to this one, and this times -3, 3 times -3 is 9. Add 2, it's supposed to be 11. Let's say I wrote 10 instead. Of course, this is going to screw up everything else afterward, and when what you get here is going to be the wrong answer. And the way you know it's the wrong answer is when I plug it into this, x plus 3y plus 6z is equal to 2. Well, it turns out if I plug this in, you can check. I just did it right now. Plug these wrong answers in. I'm going to get so -14 plus 3 times 29/9 plus 6 times 8/9 turns out to be 1, and I'm supposed to get 2. So 1 and 2. Oops, that's not right. 1 is equal to 2. Ooh, that's wrong. Same with this one. 2x plus 7y plus 5z. Put these numbers in. You're supposed to get 1. I'm getting 5. 5 is equal to 1. Ooh, that's not right. The third one turns out to work out okay. So, whatever. But that doesn't count when these other ones are wrong. So immediately I know something's wrong. I've also got some good news for you. You can actually figure out where you went wrong. Okay, so here's the idea. What you're going to do is you're going to plug these in, not just to this one, but you're going to plug it into all of them. Actually, you don't have to plug it into all of them, but let's say you plugged it into all of them. Then here we saw this was wrong. Now, what if you plugged it to this one? Of course, this is how we got this. So, of course, this is going to be right? Plug in negative 14. Negative 14 is negative 14. 29 ninths is 29 ninths. 8 ninths is 8 ninths. So, of course, this is going to be right. And that is, the matrix is wrong, but the equations are going to be true. In other words, this is true. This is yes, yes, and yes. All of this is true with these numbers. These will solve this system, but these do not solve this system. Okay. Somewhere along the way, it switched to it not working to working. So, for example, if I plug it in here, it's not going to be correct. Plug it into here, it's not going to be correct. Here, it's suddenly correct. And here it's correct, and here it's correct. So something suspicious happened between this step and this step right here. Okay, and that's how we can find your error. Actually, you don't need to plug it into every matrix. You just have to plug it in to different matrices here and there. So, for instance, this one's no, this one's yes. You plug it in the middle somewhere, like this one. You see yes. Then you're confident that maybe from here on out it's okay. But we know somewhere between here and here it's wrong. So then try this one and see no. So I don't have to actually try them all. I just kind of search around, look to the left, look to the right, look, see where it switches from no to yes. So this is a little bit of troubleshooting assistance. The book doesn't talk about this, but these problems, they're so long, you're bound to make mistakes like this. So that's a little bit of helpful hints here. Yeah, these are going to take a long time. For 3x3, there's going to be 9 steps, right? Because you're going to get ones and zeros for each of the 9 blocks, 9 numbers in the block. 4x4 is going to be 16 steps. This is going to be, and each step takes a while, right? So multiplying, adding, doing a bunch of these things. And so these are going to be long problems, okay? So sorry, that's the nature of things. And the homework, these will take some time. For the exam, I don't want to spend your entire time doing arithmetic. So I will typically ask you to do the next step. So next step meaning, okay, it's already been, I've already done this for a while. Do the next step, and you should be able to identify. Okay, these this is the order we do things. These are already done. This is the first thing that's not done. So that will tell you what to do next. And when I say the next step here, I don't mean when I combine these things like this one, and this one. This is each one step. This step and then this step. So just do one of them. And hopefully that will make the problems easier, or not easier, they're faster. You still need to know everything that there is about this procedure. You just are proving it to me by doing one thing instead of 9 things or 16 things. So here's an example. Do the next step. Okay, so pause this video and then figure out what the next step is and do it, and then unpause it, and then I will show you what the answer is. All right, ready? Yeah, this one's already here. This is the first thing I want, is this to be a 1. It's already that. And now I need to use this to turn this into a 0. So I'm going to multiply this by -6 and add it to this one. So -6 times the first row added to the second row. And that should be what happens. Okay, now here's the next one. This is a 3x3 example. I'll do the next step here. All right, ready, pause. All right, are you all done? Okay, so this first column is already as it should be. This next column, this one's a 1, that's good, but these other things have to be a 0. So the first one I try to make this a 0 would be this one. I mean, you could do either one, but like I said, let's go from top bottom to keep things orderly. So let's do that. -4 times the second row added to the first row will turn this to a 0. And there we go. All right, so your exam will have a bunch of things like that. All right, so the next question, does this always work? So I tried with lots of different examples here. Um, Sometimes you need to get zeros, sometimes you need to get ones. To get a zero, you can always use operations of type 3. I've indicated that. You just take the negative of the number and just add the multiple of the whatever row has the 1 to the row you want to change. That always works. Okay. To get a 1, that almost always works. You use operations of type 2, right? So if you have a 9 and you want to turn it to 1, you just multiply by 1/9. The only exception is when there's a 0. Okay, if there's a 0 here, no amount of multiplying by here by anything will turn this into a 1. Okay, so this is the problem. This is the one exception. What do you do when there's a 0 here and I want to turn it into a 1? Well, that's when we use operations of type 1, that is swap two rows. Remember that operation that we never used? Well, okay, this is the only situation where we use it. And we're going to swap this row with, we only swap, so this is the row with the bad 0. We only swap it with rows that are beneath it. Never swap it with something above. Okay, so here's what you're going to do. Yeah, need a 1 here. Operations of type 2 will not work. We're going to swap rows 2 and 3. Okay, always swap this one with the bad 0 with the row beneath it, so that the number is not 0 anymore. So there we go. So you notice this 0 is here and the 9's here. Let's swap these two. Oh, one important thing. We're swapping the entire row. So 0085 becomes 0085 down here. 0947 becomes 0947. You don't just swap these numbers, right? You have to swap the entire row. Because swapping two numbers is not one of the elementary operations. Swapping rows is an elementary operation. So there we go. Swap these two rows. And now this is not 0 anymore. And I can multiply by 1/9 to turn it into a 1. You know, we are back in the game. Okay. So that will work. Oh, why not swap it with a row above? If I swapped it with this row, that's really tempting because this is already a 1, right? But notice if I did that, then this first column will get all messed up. And we will not allow that to happen. Okay, so never swap the bad row with a row that's above it. Only swap with rows that are below it. And of course, the whole point is to swap with a row where this is not 0. So if there are a whole bunch of zeros down here, you got to pick one where it's not 0. What if there are only zeros under it? Like here in this case, right? There are only zeros beneath it. What do you do? Well, you can't swap with a row above it because that would mess this up. You can't swap with a row below it. Well, you can, but it won't help you, right? It's still going to be 0 here. So what do? You give up. No, you don't give up. But you almost do. What you do is you give up on this 0. Okay, you give up on turning this into a 1, and just move to the right. So here, we're no longer trying to get this to be a 1. You're going to make this a 1, this one into a 1. All right. When I do this, you might think that I've gone off my game here. I'm no longer trying to get the ones on the diagonal, and indeed that is correct. In this situation, it's impossible to get the ones down the diagonal. But it turns out that if you do it this way, and only do it in this circumstance, don't do it when you could have swapped with a row beneath it, but only in this case, it turns out that the result is almost as good as having ones down the diagonals and zeros everywhere else. So we're going to talk about that some more another time. But first of all, let me just summarize what's going on. You're going to start in the upper left. You're going to try to get this to be a 1. This is how. If it's not 0, multiply the row to make it 1. I guess this includes the case where it's already 1, and you multiply it by 1, or just skip it, it's already a 1. If it's 0, and try to make it a 1, try to swap with a non-zero entry below it, and it's a whole row. Okay, so look below it, see if there's a non-zero entry below it. If it is 0 and everything under it is 0, then move to the right. So all of this is in order to make this a 1. Once I get this as 1, then I use it to clear the rest of its column to 0, and then move down into the right. So here is my first one. I'm starting in the upper left. I want to turn this into a 1. Okay, let's say I succeed. And maybe one of these things does it, right? Now, once I succeed at making this a 1, I'm going to clear the rest of its column to 0, using operations of type 3 to each of these to turn each of these question marks below it into zeros, like that. And then move down to the right. That is, I'm now looking at this one. Okay. Sometimes people call this a pivot. These things in boxes that I'm turning into a 1. You don't need to know that word. Okay. Again, I'm trying to make this a 1. What if it's 0? Okay. So if it is 0, then I'm going to try to swap with one of the non-zero entries below it. Like, okay, this is 0. That's no good. 3, 7, one of these. So this row is going to be swapped with, let's say, this row. If you want to be very systematic about it, say the first non-zero entry here. This one, by the way, I'm not even going to pay attention to because I'm not going to swap with this row. But look down here. Aha, this 3 here. I'm going to swap it with this row here. So there we go. This is a 3. This is now a 0. All these other question marks swapped as well. You didn't see it because I put question marks there. And now I'm going to turn this into a 1 using our age-old operations of type 2, multiplying this by 1/3. So again, I put it back here. And then I use that to make everything else zeros as before. Go down to the right. Okay, move it down into the right here to make this one a 1. Let's say this is a 0 and everything under it is 0. In this case, move to the right. Okay. So I'm not going to try to make this one a 1. I can't. I'm going to try to make this one a 1. Okay. And maybe I succeed, maybe you don't. Let's say I succeed, right? Then once I get this to be a 1, I clear everything else in this column to 0, and then I move down to the right. So you see, this is no longer going down the diagonal. It's going down this diagonal and then jumped over a little bit. And now it's going down the diagonal. And this one, again, you're going to turn into a 1 somehow. We hope anyway. Let's say I succeed, then everything else in its column will be 0. And same with this one. I turn this into a 1, or I hope to turn it into a 1. Use it to clear everything in its column to 0. All right, so this is how we do Gauss-Jordan elimination or Gaussian elimination. And then you're going to read these off like this. Now, what happens when you can't have these diagonal things? That's going to be a subject for next time. Okay, so thanks for listening. I'll see you next time.